objective of this video is to explain full restraints. Now before going into detail of full restraints, just like to explain the deflection and rotation of the beam. So if it is supported and it's loaded, this beam is trying to bend. So they have a x-axis which is coming out of this beam, z is along the length of the beam, and y is in the downward. So there are three axes that we're going to use as a reference for describing the deflection and rotations. Now the first deflection that we got under this loading condition is just vertically down in the y direction. So you think of these beams trying to bend and they have a deflection in the y direction. If I take the ruler here and if I consider this is the top flange, which is this flat portions, and under the bending it's try to bend in the y direction. So you can imagine that if you have this one, this will go in this fashion, and they have a deflection in the y direction. That's the first deflections. Now the next deflection that you get, it is a lateral deflection of the compression flange. So under this loading condition, this is compression flange, this is tension flange, and that is wave. Under that conditions, between the point of lateral restraints, for example in the x direction, this beam try to do the lateral deflection. If I don't have any restraint in these directions, what happen in this, for example these rulers, if I take it this steel beam in this one, under this loading condition it try to laterally come out. So for example you can have a displacement in the x direction, that is called lateral deflection. Vertical deflection, lateral deflection. Vertical deflection in the y, lateral deflection in the x. Next moment is the twist of the beam cross section about the z axis. So if you are thinking of this one, this bottom flange is straight, but this flange is try to twist. So in that because the bottom flange remains essentially straight, but the top compression flange moves sideways, the wave must tilt away from the vertical, create a twist and rotation of the beam. So third is the twisting of this compression flange about the z axis. So you can take the twisting about the z axis. The last one is a lateral rotation of the compression flange of the location of the lateral restraints. For example, rotation about the y axis, that is look into plane. So the last one is particular this plane, then is about y axis, and it's try to rotate about the y axis. So we describe two rotation and two displacement. One displacement in the y direction called vertical displacement, displacement in the x direction called lateral displacement, and there are two twist or rotation. First rotation about the z axis and second rotation about the y axis. So in the beam we have four scenario, two displacement, two rotations. Now what is the full restraint? So there are four scenarios that you need to keep in mind to describe this full restraints. Now full restraints is given in the clause 5.2.4 on page number 55 in AS 4100. On the clause 5.4.1 it has full restraints, it has given A and B. You are allowed to read this one, and it has also described it in the figures. Now I just take the quick notes from that Australian standard, which is full restraint is equal to lateral restraints of the compression flange. What does it means? I explain you lateral restraints, which is actually coming in the x direction. So if I put some beam along this, if I put the connection here with the beam like this one, so in that case these beams is not going to do the lateral displacements. So full restraints means lateral restraint of the compression flange plus full or partial restraint of cross section against the twisting. So that's description of full restraints, or we can say lateral restraint of some other point of the cross section other than compression flange, or the full restraints of the compressions against twisting. So there are two scenarios to describe the full restraints. Now in summary, full restraints means complete privation of lateral moment of the compression flange plus at least partial restraint of twisting of the cross section. So it's just full restraints, meaning there is no lateral moment and partial twisting. So about about this z-axis, the twisting is not partially restrained. If I describe it in the figure, so if for examples we have columns and this is website plate connector with the beams, so if you are taking this scenario, these website plates prevent the restraint of this critical flange, so it's have a lateral restraints and partially twisting. This website plate is not strong enough to prevent the twisting, so there is a partial twisting. So in this scenario, this end is considered as a full restraint. Thank you.